Hey, this is Brian. I'm the founder of SensorTracks and doing some videos on how to calculate OEE. So I thought I would use our OEE calculator on our website. It is free. You can get to it from the Google machine. Just type in OEE calculator or the Bing machine or Wikipedia or all kinds of places because it's a pretty good calculator and it's free. Did I mention it's free? So what I'm going to walk through today is what is OEE, how you calculate it, what the formulas are, a little bit around this tool and how you can use it, and then a shameless plug for our software at the end. Of course, I have to do that. So this is our formula, our calculator, and we have a calculator where you can adjust a lot of the input parameters. It'll show you different components of OEE, which we'll talk about, and results based on what you put in. It'll also show you all the formulas. Formulas are cool, but it'll substitute the actual values for you too. So you'll know based on what you put in, what the actual formulas are, so you can kind of play around with it and see how it works. We might build one of these for Excel too in another video. So if you want to build your own, if you don't want to buy our software and you want to use Excel, you can do that. So what is OEE? OEE is a metric that somebody came up with a while ago, like in the 80s. There's an article on it if you want to Google it. A lot of people use it. It's become kind of a marketing term at this point. The way people use OEE is a little different in every organization, which is fine. And at the end of the day, when people say, hey, we want to track OEE, what they really want to look at are the components of OEE, which is performance, quality, and availability. So we'll walk through each one of those. But the way you get OEE is you multiply these three numbers together. Those numbers are typically expressed as percentages. You multiply them together and boom, you get OEE, which is also a percentage. Because we're multiplying three numbers together, three percentages together, a single OEE number can represent very different things from an underlying data perspective. So it's a good thing to know, and we'll look at some examples of that. So let's start out with the calculator, the different parameters that you can put in it. You can do shift start and shift end. So when does my shift start? When did my shift end? This only deals with a single shift, but you can kind of get the idea of how you can do multi-shift calculations as well. How much planned downtime did we have? So you can enter that in minutes. How much unplanned downtime we had? You can enter that in minutes. Total parts produced, including scrap. Your ideal cycle time, how fast should we be running? Some people call these standards as well, the standard for the machine. How long should it take to make a part, or how many parts should we make in a certain amount of time? This is minutes based. This whole calculator is minutes based. If you want to do it in seconds, multiply minutes by 60. If you want to do it in hours, divide minutes by 60, and you can get those calculations. Check out the cycle time video. It talks about how to do that. And then how much scrap do we have, which is used in the quality calculation. So those are our different inputs, and we'll talk about how each one of those goes into it. So first, let's talk about availability. Availability is how much of my available time did I actually run? And this result is used in other places as well. So the first step in that is how much available time do I have? So in this calculation, we're looking at a single shift from 7 a.m. to 3 p.m. So we have 480 minutes in which to do our production. That's our available time. There's also the concept of TEEP or OPE, basically looking at the available time as a 24-hour period. I don't love that because while it does show you what you could be producing in a 24-hour period, adding a second shift and adding a third shift is a pretty monumental change in your organization. It requires a lot of discussion and a lot of research and justification to actually do that. So you know that you have excess production there. That's basically my point. And you know what you could achieve theoretically by adding those additional shifts. So I don't see a lot of value in that. I measure the shift schedules, like first shift goes from 7 to 3, second shift might go from 3 to 11, and so on. So that's our available time, 480 minutes in this particular example. So we can adjust that. So let's say you go from, maybe it's a 12-hour shift, right? 7 to 7, okay? So now the number of minutes in our calculator goes up to 720 from 480. You also notice that the OEE calculations changed. We'll talk about that later, but they did change. So the second part of this is, well, you'll think to yourself, Brian, What about planned downtime? I don't want to include that in my calculation. There's certain days where it's just not scheduled to run, like we just don't have the work. Or I don't want to count lunches and breaks because I'm never going to eliminate lunches and breaks. So I want that taken out of my available time. So what that is it's taking shift length and subtracting your planned downtime, which you get your planned production time. So in this case, we have planned downtime of 30 minutes. And so with 720 minute shift length, we get 720 minus 30 equals 690 minutes for our shift. Okay. So the next step of calculating availability is I got to figure out my actual downtime. So my unplanned downtime. And the formula for that is planned production time, so the answer we got above, 690, minus our unplanned downtime. So right now we have no unplanned downtime, so our total operating time is 690 minutes. So if we take a look at that, which gives us an availability of 100% because we have no unplanned downtime. So what's interesting about this is you can muck around with planned downtime all you want, and you'll notice as I change this, availability does not change. So availability is not affected by planned downtime, but what is? Performance. We'll look at why when we get to the performance calculation. What does adjust your availability calculation is unplanned downtime. So if I put in 30 minutes of unplanned downtime, now it drops my availability down to 95%, and I can adjust this around to get different values, right? Now I'm down to 91%. Performance continues to adjust, which is super interesting, right? So performance goes up when you it goes down when you remove unplanned downtime. When you add unplanned downtime, it goes up. Super interesting. We'll talk about why soon. So now let's look at that. So planned production time minus unplanned downtime equals operating time. So 651 minus 60 equals 591. Okay, so the values change because I was messing around with planned downtime as well. So we ended up with 651, which is used here, and then minus 60, 691. Okay, so then what is our actual availability number and how do we calculate that? Well, it's operating time divided by planned production time. So our operating time is 591, planned production time is 651, and so that's how we end up with 90.78%. So you'll notice that we're using planned production time, which does not include planned downtime. So planned downtime can and will affect your OEE calculation, but it will not affect your availability if you use the calculations the way we're doing it. So now let's talk a little bit about performance. So performance is a measurement of how close you're coming to your ideal or standard cycle time in terms of rates of production. So if I should be able to produce 10 an hour and I only produce 9, then I'm at, what do you think? 90% performance. If I can produce 10, I'm at 100%. So here's the math on that. It is 1 divided by the ideal cycle time, expressed in minutes, this is minutes, times the operating time equals capacity. So how much can I make? How many minutes do I have, right? How many can I make in a minute? How many minutes do I have? That's my capacity. That's how much theoretically I could make during the time that I was running. So this is operating time. This is the result from this calculation up above, which is why downtime, planned downtime and regular downtime and those kinds of things can adjust your performance numbers, because the output of that calculation is an input of this one. So in this case, it's very simple. It's 1 divided by 1, because the ideal cycle time is 1 part per minute, or 1 minute per part, either way. Okay, so we should be able to produce 591 parts in the time that we have, which is 591 minutes. Okay. So then let's look at the rest of the formula and we'll play around with it. So your availability formula, your performance formula is total parts produced divided by the capacity number up above, or the ideal, the target, the amount that you could produce in that amount of time. So 400 divided by 591 equals 678. Okay, so let's mess around with some of the inputs to that one. Let's say our ideal cycle time was 2 minutes per part. Our capacity goes way down, but the total produced stayed constant, so our performance went through the roof, right? Super interesting. So let's say it was 1 again. Now, let's mess with our total parts produced. So let's take it from 400 to 500. Now we're much closer, right? 85% performance. Let's take it to 580, 98% performance. Pretty cool, right? So that's how the performance metric is calculated. And you may be able to start to see how, a single OEE number, which is 88%, can have very different underlying numbers, very different performance, quality, and availability numbers. You could have, they can vary and still come out to 88%, which is why looking at OEE by itself is not always a great thing. And I think it's why, most people, when they talk about OEE, they're talking about, collecting this data and measuring and monitoring these 3 things, availability, performance, and quality, and then also some other things as well. So let's look at quality. So what's interesting about quality is that the performance calculations are an input to the quality calculation. So quality is total parts produced minus the scrap. So basically that part of the formula is how many good parts did I make divided by total parts produced equals quality. So in this case, we made a total of 580 parts, 10 of them were bad, divided by 580, 98.28% quality. Okay, probably the easiest metric to understand out of all of them. And then to get OEE, you multiply the 3 of them together and boom, OEE. So 0.91 times 0.98 times 0.98, 87.56. So let's play around with this a little bit and see how we can come up with the exact same OEE numbers based on different inputs. So I'm going to kind of reset this back to where it was. So 7 to 3, we're going to have 30 minutes of planned, no unplanned, 400 parts, okay, and everything else will be the same. Okay, so let's say that we increased planned downtime to 60 minutes. Okay, so it changed. So our OEE went to 93% from 87%. So let's say it's 60 minutes. Now check this out. Now it's 87% because our performance went to 89. Wait, what did I do there? So let's go back, turn it to 3 o'clock, turn this back to 30. Okay, so this is 89% performance, but we have 30 more minutes of planned downtime. Okay, and I'm adding 30 minutes to the shift, so now it's 89% again. Kind of weird, right? So one of the other things that we could do though is let's take out planned downtime altogether. Let's throw in unplanned, okay? And we're trying to get to, let's say, 76%. So how could we manipulate these things to maybe increase performance, decrease availability, and still end up with the same number? So we're going to mess around with unplanned downtime. So I put in 30 minutes of unplanned downtime, and look what happens. Same OEE number. My performance went up, my availability went down, but I have the exact same OEE number. 60, same OEE number. 100 minutes of downtime, same OEE number. And the underlying numbers of this are very different based on what's happening. So it makes it hard to really understand, looking at a single OEE, what's happening on the line without the other 3. And you could do this by manipulating quality. You could do it with downtime, performance. It doesn't really matter. The point here is that it can be easily manipulated, and it can be pretty misunderstood if you don't have the context and the other values around it. So hopefully you got some value out of this video and learned how to calculate OEE. Just a reminder and a shameless plug, SensorTracks is a manufacturing productivity platform that can do this for you automatically. It can give you OEE, all the underlying components, and all the context associated with it in real time for your whole plant, your whole company, individual machines, people, parts, whatever, automatically. So check out our website, sensortracks.com, and check out the other videos too. Thanks.